Good morning, all. Now, today we'll be studying about our second chapter from our NCRT book, that is about the polynomials. Now, in this chapter, uh, we will first have a small introduction about the polynomials. What do you mean by a polynomial? How we can identify it? And second is about the zeros of a polynomial. Zeros of a polynomial we have already studied a bit in class ninth also, where where we have already done about the factorization part, right? Now here it will be the same, almost the same. Now the first thing that we should know is, what do you mean by a polynomial? Now if any p of x is a polynomial in x, the highest power of x the highest power of x is known as the degree of a polynomial. Now, let us say, for example, we have an equation like y is equal to x cube plus 3x square plus 2x plus 8. Now, in this whole equation, the highest power was 3. Therefore, its degree will be known as 3. Uh, let us try to understand this with a few examples. First of all, any polynomial of degree 1 means the equation have any variable with the highest degree as 1, or with the highest power of any variable as 1, then it is known as a linear polynomial. For example, 3x plus 5 or y plus 2 or x minus 3 or z plus 4. As you can see, all the variables in this x, its power is 1. Therefore, it is a linear polynomial. Why? The power is 1. Therefore, it is known as a linear polynomial because the highest power is 1. Any polynomial of degree 2 is known as quadratic polynomial. Means if I change this as 3x square plus 5, it will be known as a quadratic polynomial, like this, 3x square plus 5. Why it will be known as a quadratic polynomial? Because its variables are having the highest power as 2. Similarly, if I change the degree to 3, it means the highest power will become 3. Then it will be known as a cubic polynomial, like this, 3x cube plus 5. Now x cube, when we say x cube, it means it will be of degree 3, or it will be known as a cubic polynomial. Next comes about the zeros of a polynomial. Um, Zeros of a polynomial means how many factors are there which can divide that particular equation. Like, for example, if I try to explain it through a graph, the number of times any graphical line or a curve intersects the x-axis, the number of times any graphical line or a curve intersect the x-axis is also referred to as the zeros of a polynomial. Now I have taken few examples from the NCRT book, like this. Now these are the three different examples. As you can see, this is x-axis and this is y-axis. Now this particular curve, how many times it is intersecting the x-axis will be the number of zeros of polynomial. Like, for example, this line is cutting the x-axis only here. It means its number of zeros will be equal to 1. Here you can see that the curve is intersecting at two places, one here and another one here. It means the number of zeros of this polynomial will be equal to 2. Similarly, for this third graph also, 1 here, 2 here, and third one here. Therefore, the number of zeros of this particular graph will be equal to 3. Now, uh, there is a small relationship between the zeros of a polynomial and its coefficients. Now let us say, for example, I have taken this equation ax square plus bx plus c. Now this is a quadratic polynomial. Why? Because the highest degree here we have seen is 2. Now let alpha and beta be the zeros of the polynomial. We have to find the values of these alpha and beta also. Now there is a relation between the coefficients of a polynomial and its zeros. Now these are known as the coefficients. This a is a coefficient of x square, b is a coefficient of x. Alpha plus beta means if I add on the two zeros, what are the two zeros? I don't know. We have to find it. These two zeros, if we add them, we will get the value as minus b upon a. It means minus b upon a. Similarly, if I multiply these zeros, means alpha into beta, then the relation will be c upon a. Alpha plus beta is minus of b upon a, minus of b upon a, and alpha beta is c upon a. Now, what is this b? B is the coefficient of x. Let us say some equation comes ax square plus c only. In that case, b will be equal to 0. I repeat my point. Let us say, for example, the quadratic polynomial is just ax square plus c. Now in that case, b is equal to 0 because we don't have any variable x. We have x square, therefore the value of a will be its coefficient only. Now, ax square plus bx plus c, let us explain it with the help of an example. I have taken an example as 2x square plus 3x plus 8. Now, as per this question, the value of a will be equal to 2, b will be equal to 3, and c will be equal to 8. Now, the relation between their zeros, alpha plus beta, is equal to minus of b upon a, means minus b upon a. Therefore, here alpha plus beta will be equal to minus 3 upon 2. Minus 3 upon 2. Why? Because we have minus b upon a, means this value upon this value. Therefore, here also it will be minus of 3 upon 2. Alpha beta was c upon a, means this value upon this value. Here it will be 8 upon 2, like this. Another example, I have taken a question from your NCERT book. Second exercise. First exercise is completely based on to find the number of zeros using that graph method. Second exercise, we have, let us say we have to find the zeros of the quadratic polynomial x square plus 7x plus 10, and we have to verify the relationship between the zeros and the coefficient. Now, every time I have been telling you about that your examinations will be having this particular question, or this is the shortcut question. Again, it comes under the category where we are damn sure that we'll be getting a question on this. Now, this is the equation. We have to do two different things here. First is we have to find the zeros, means the values of alpha and beta. And second is that we have to verify their relationship. Now, how to find the zeros of a polynomial? We just have to factorize it, right? We have to factorize this equation by splitting the middle term. So, x square plus 7x plus 10, as you all know how to factorize it. If not, then what are the two factors of 10 so that its sum or difference should be equal to this middle term? 10 can be factorized as 5 into 2, and 5 plus 2 will give you 7. Therefore, x square plus 5x plus 2x plus 10 because 5 into 2 will give you 10 and 5 plus 2 is giving you 7. Hence, taking out the common x, we will have x into x plus 5 plus 2 into x plus 5. We have taken 2 common from here and we have taken x common from here. When these two are similar, we can write this as x plus 5 and x plus 2. Hence, the two zeros of a polynomial are minus 5 and minus 2. We express these zeros in the opposite sign as given here. Why? Because we can have x plus 5 is equal to 0. If x plus 5 is a 0 of a polynomial, we can write it as x plus 5 is equal to 0, or we can say x is equal to minus 5. Similarly, x plus 2 is equal to 0 or x is equal to minus 2. Now, these are the two values of alpha and beta. Alpha comes out to be minus 5 and beta comes out to be minus 2. Now, these are the zeros of a polynomial. Our first part is done. Second part is to verify its relationship. How to verify it? Always remember that the general equation was ax square plus bx plus c, and the given equation is x square plus 7x plus 10. Therefore, the value of a will be equal to 1 here, b will be equal to 7 and c will be equal to 10. I repeat, as per this general equation, the value of a will be equal to 1, b will be equal to 7 and c will be equal to 10. According to that relationship, alpha plus beta, it was minus of b upon a. Minus b upon a means minus 7 upon 1, which will give you minus 7. Now just verify it from here. If I add these two, what will I get? Minus 7. This is what I am getting. Minus 7 here. Hence, first relation is verified. Second relation, which says alpha into beta, and alpha into beta was c upon a. It means alpha into beta will be equal to c upon a, or 10 upon 1. Means this is now alpha into beta. Now if I find alpha into beta from here, I will get minus 5 into minus 2 as equal to 10. Hence the relation is verified. Now please go through exercise 2.1 and 2.2. It's very easy now. I request you again and again, you all are not watching your videos properly. You have to watch it completely. If you are not able to understand once, ask me, or else watch the videos again and again. That's all for today. Thanks. Stay healthy and stay safe.